Welcome to Chetan Bharat Learning. So like every Tuesday, today we are going to discuss current affairs related to the field of science and technology. Alright, so we'll discuss all the important developments with respect to the field of science and technology for your UPSC preparation. Now our period of reference for this particular discussion video would be from 6th of October to 12th of October. Alright, so let's take a look at the issues, science and technology related issues that were important in the past week. Okay, there weren't many issues that were important with respect to science and technology. Actually, the only thing that was important was Nobel Prize for Physics and Chemistry. So most of our discussion in today's video would be restricted to these areas only. All right. Nonetheless, we'll take a look at issues to be covered. First, we'll discuss Nobel Prize for Physics. Why is it? For which work? For which field? Nobel Prize for Physics was awarded this year. What were the contributions to the? What were the contributions made by people who were awarded with this prize? We'll take a look at all of that. Then we'll take a look at Nobel Prize for Chemistry. Then we'll talk about a controversy that erupted this year, Nobel Prizes in the field of sciences for women. It was found that of all the awardees, if we take a look at all the awardees, if we take a look at all the people who got these awards, Nobel Prizes, there were 178 male scientists and 9 female scientists. Now, that's a very skewed ratio. That means there is some form of sexist bias in favor of males. It is not that female scientists have not contributed towards the field of science and technology. They have, but very few female scientists receive Nobel Prize. All right. So there was this controversy that erupted. So what I've done is I've taken certain screenshots from various articles and I've provided you those screenshots in your notes itself. So that's the third issue. And in the end, we'll talk about SMART test and its significance. Now, what is the SMART test? This is defense-related news. DRDO actually tested a missile or a torpedo, which is called SMART. And what would be that torpedo's significance and all the issues revolving around this test? We'll discuss all of that. All right. So without further ado, let's take a look at Nobel Prize for Physics. Okay, now this particular topic, this particular issue, Nobel for Physics, actually dominated the news circles, news headlines, all right? So there were many articles in many newspapers with respect to this. Now, I have shortlisted some articles, few articles that would cover your UPSC syllabus, all right? 2 articles were from Indian Express and 1 was from print. Now, the Nobel Prize for Physics this year has been awarded to 3 people, 3 scientists, for their contribution towards understanding black holes. All right. So astrophysicists who have contributed towards understanding and discovering black holes have been awarded Nobel Prize for Physics this year. All right. So let's take a look at the names of those scientists. Royal Swedish Academy of Sciences decided to award one half of 2020 Nobel Prize in Physics to Roger Penrose and the other half jointly to Reinhard Genzel and Andrea Ghez. By the way, before starting with this news, I would like to say that if you want to know each and everything about Nobel Prizes, how many Nobel Prizes are there, which Swedish and Norwegian institutes award these prizes, all these details were discussed in the previous science and technology video. So if you don't know about Nobel Committee, Nobel Prize, the institutions that provide Nobel for physics, for economics, all this information, all this trivia, if you don't know anything about that, then I would advise you all to check the previous science and technology related video after this video. All right. Today we are going to restrict our discussion to Nobel for Physics and Nobel for Chemistry only. Okay. Yeah. So Royal Swedish Academy decided to provide, it's actually split the Nobel Prize for Physics this year. One half was given to Roger Penrose and the other half was shared by Genzel and Ghez. All right. Now, what was Penrose's contribution? Roger Penrose, along with Stephen Hawking, actually showed that what Einstein predicted in his general theory of relativity. Einstein actually speculated that there can be objects like black holes in the universe, but Einstein said that it's a theoretical possibility in the universe. Einstein was not sure whether black holes exist or not. All right. Now, Einstein, while publishing General Theory of Relativity in 1915, talked about theoretical possibility of black holes. Einstein died in 1955, and 10 years after his death, two people actually took Einstein's work forward, and they mathematically proved that black holes, the formation of black hole, the formation process of black holes is actually stable, and therefore black holes can exist and do exist in the universe. All right. Now those two people were Roger Penrose and Stephen Hawking. Now Stephen Hawking is dead, and as you guys already know, that Nobel Prize is not awarded posthumously. I mean, dead people don't get a Nobel Prize. Therefore, the only surviving member of this duo, Roger Penrose, received this prize this year. Now he received this prize for his work way back in 1965. He actually proved that black holes are possible. They are practically possible. They are not just a theoretical concept according to Einstein's theory of relativity. They are practically possible. Their formation process is actually stable, and they do exist in the universe. He proved all of that, he and Stephen Hawking, way back in 1965. Now that is why when many people are criticizing the Nobel, Royal Swedish Academy of Sciences, that they have been, they are quite late in awarding Roger Penrose with this prize. It's quite late now. But again, better late than never. All right. Okay, they have been, we'll talk about the contribution made by Genzel and Guess. First, we'll talk about the contributions made by Roger Penrose. They have been awarded this prize for their contribution towards understanding black holes and the most enigmatic objects in the universe. Now, what are black holes? Black holes are those compact objects in the universe whose gravitational field is so strong that even light cannot escape from it. All right, here's the definition of black hole. A black hole is formed when stars collapse and can be defined as a space in the universe with an escape velocity so strong that even light cannot escape it. Now, black holes generally are formed when a big massive star collapses onto itself. All right, when a star collapses onto itself due to its force of gravity, it confines itself into a very small space. Now all this mass is confined into a very small space, and hence black holes are quite dense. Plus, black holes have extreme levels of gravity. All right, now massive stars collapse to form black holes. When a star dies, it actually explodes into a supernova, and after that supernova explosion, it collapses onto itself and forms black hole. But smaller stars like our sun cannot collapse completely. They do collapse after exploding. They do collapse, but the end result is a white dwarf. So massive stars are capable of forming black holes. Smaller stars are capable only of forming white dwarfs. Nonetheless, black holes are very hard to detect. Why? Because of the reason I just mentioned. Black holes, to observe any object in the universe, to observe any celestial object in the universe, that object needs to emit light. Right? If a star is emitting light, you can detect that light, and you can detect that particular star in your telescope. Right? But black holes are dark objects. Black holes have a gravitation so strong that even light cannot escape it. Now, if light is not escaping light cannot escape these black holes, then how would anything reach our telescopes, and how can we observe these objects? Right? Hence the name black hole, because light cannot escape it. Therefore, it is very hard to observe them. Okay, makes sense? Now, what do we mean by escape velocity? And why is it mentioned in the definition of black holes? Now, what is escape velocity? You know, Earth has a gravitational field. Now, how much speed an object needs to gather to escape the gravitational pull of Earth? That would be known as escape velocity of Earth. Right? So a particular object, when it is moving away from Earth, it needs to gather momentum. It needs to gather a particular amount of speed, a certain amount of speed, so that it can completely escape the gravitational pull of Earth. That would be escape velocity of Earth. Similarly, black holes also have gravitational pull, and similarly, black holes also have escape velocity. But the escape velocity is so high for black holes that even light cannot escape it. Now, the speed of light is 3 into 10 to the power 8 meter per second. And the speed of light is the highest speed that any object in the universe can achieve. All right? It is the highest speed that anything in the universe can achieve. So this is the highest speed. And not even this. Even this is not the escape velocity of a black hole. Even an object traveling at a speed equal to the speed of light cannot escape a black hole. Its gravitational pull is so strong. All right. So this is the definition of escape velocity. Now let's take a look at the diagram of black hole. Now you don't need to look at this diagram, because this diagram actually, or this shape of black hole actually adds the dimension of time, and it will be very complex for you to understand 3D plus time dimension, 4-dimensional figures. It will be very difficult, and UPSC won't ask you about it. So let's take a look at the 3-dimensional picture of black hole. Now this is how a black hole looks. All right. At the edges, circumference of a black hole lies the event horizon. All right. Now, what is event horizon? The gravitational pull of a black hole is so strong. And by the way, Einstein actually explained in his general theory of relativity that the source of gravity is bending of space and time. All right, bending of space and time. Newton actually did not discover gravity, or Newton did not actually explain the source of gravity. All that Newton did was he measured gravity. It was Einstein who explained gravity, and he explained it by saying that it's nothing but distortions in the fabric of space-time. Okay, when space and time bend, they create a gravitational pull. All right, now black holes gravitational pull is so massive that space and time bends. As a matter of fact, their gravity is so strong that after this event horizon, time stops. And as you guys already know, that events actually happen in time, right? Whatever I'm speaking, whatever sentences I'm omitting, they are happening along with time. If time stops, events stop. And that is why this is known as event horizon. If you cross this event horizon, events would cease to happen because time would cease to exist. All right. Now, generally, many stars and many objects revolve around this event horizon. And some of them actually enter the event horizon and they are lost forever. Some are still revolving around. Now, many stars who are revolving around this black hole, they emit light. And through their light, through their electromagnetic radiation, we can detect black holes. All right. At the center of a black hole lies singularity. And Robert Penrose and Stephen Hawking actually did some work on explaining singularity also. All right, makes sense? All right, let's move forward. Let's take a look at Roger Penrose's work. Penrose's work has shown that black holes are direct consequence of Albert Einstein's general theory of relativity. When Albert Einstein presented his theory of relativity, general theory of relativity, actually Einstein came up with two theories of relativity, general and special. When Einstein came up with general theory of relativity, he actually explained that time is relative. Time is relative. That means my time can be slower than yours, or your time can be slower than mine, and time is actually relative. Plus, he actually explained what gravity is. And while explaining the phenomena of gravity, he actually predicted that theoretically, mathematically, it is possible that in the universe, there are these super compact objects who have gravitational pull whose gravitational pull is massive, close to infinity. Okay, now, after Einstein's death, two people worked further on this, Roger Penrose and Stephen Hawking, and they explained that it's not just a theoretical possibility, black holes can actually exist, and black holes actually exist, not can, they exist. Einstein himself did not believe that black holes exist and presented his theory in November 1915, providing a new way to look at and understand gravity. Penrose used Einstein's general theory of relativity in order to prove that the process of formation of black holes is a stable one. He proved that black holes exist and described them in detail back in 1965, 10 years after Einstein died. Okay, in 1965, 10 years after Einstein's death, Roger Penrose and Stephen Hawking, the late theoretical physicist, Stephen Hawking, we all know about Stephen Hawking, right? Proved mathematically that black holes can form. They all explain the singularity, okay? At the heart of the black hole, where gravity and density approach infinity, and all known laws of nature cease to exist. Time ceases to exist. All known laws of physics, laws of nature cease to exist at singularity. Penrose and Hawking's work, called Penrose-Hawking singularity theorems, is considered to be one of the most groundbreaking papers published in theoretical physics. Hawking was not awarded the Nobel. Of course, why? Because Nobel is not awarded posthumously. The one who dead people don't receive a Nobel Prize, right? So that is why people criticize. It would have been better if Stephen Hawking, along with Roger Penrose, received this award. But Stephen Hawking unfortunately died, and he could never receive this prestigious award. The only surviving member of this duo, Roger Penrose, received it. That is why people say it is too late. All right, their work was groundbreaking. They should have been awarded with this prize way too early. All right. Okay, let's take a look at what Genzel and Guess did. What Genzel and Guess did was, Genzel and Guess actually discovered a supermassive black hole that lies at the center of our galaxy, Milky Way. It is believed that all the galaxies at their center have a supermassive black hole. There is a supermassive black hole at the center of each and every galaxy, and around that supermassive black hole, all the stars of that galaxy revolve. So this supermassive black hole that Genzel and Guess discovered at the center of Milky Way is the center around which the entire Milky Way revolves, because its gravitational pull is so strong that the entire galaxy revolves around it. All right. Now, they were able to detect. It was again a theoretical possibility that black holes, supermassive black holes, lie at the center of each and every galaxy. But they were successful through their telescopes, through their experiments. They were successful in detecting this, the supermassive black hole that belongs to our galaxy, Milky Way. Genzel and Guess shared the other half of the prize for the discovery of a supermassive compact object, that is the black hole, at the center of Milky Way. This is thought to be our galaxy's central supermassive black hole called Sagittarius A star. Star means asterisk, okay? Pronounced Sagittarius A star and abbreviated to Sagittarius A star, okay? Supermassive black holes are the biggest of their kind. They are the biggest black holes that exist in the universe, weighing millions to billions of times the mass of our sun. They are thought to exist in the center of every galaxy around which the entire galaxy orbits. Okay? Since the 1930s, it was known that there was a strong source of radio waves at the heart of Milky Way. Now, this supermassive black hole was emitting radio waves, radio wave radiations. In 1930s, we were able to detect those radio wave radiations, but we couldn't guess the source of these radio wave radiations. All right. Radio waves at the heart of Milky Way coming from the direction of constellation Sagittarius. The radio source was called Sagittarius A star because it was exciting. Genzel and Guess separately observed the movement of planets closer to this source of radio waves and separately published. They both did their work separately. Separately published evidence for existence of supermassive black hole at the center of Milky Way having a mass 4 million times that of Sun. 4 million times that of Sun. This black hole's mass is 4 million times that of Sun. All right. Okay. Now, we'll jump to the next news, which is Nobel Prize for Chemistry. Again, there were two articles that are important for studying this particular news. One was in the Indian Express and the other was in the print. So let's take a look at Nobel for Chemistry. In 2020, Nobel Prize in Chemistry Wednesday was jointly awarded to French microbiologist, geneticist and biochemist Emmanuel Charpentier and American biochemist Jennifer A. Doudna, both of them are females, for their work on development of CRISPR-Cas9. Now, CRISPR-Cas9 is a technology that is used for gene editing. Gene editing. Now, what is gene editing? As you guys already know that our genes actually describe us. Our genes are responsible for all the features we have. Our genes are responsible for all the characteristics we have. Not just we. Each and every living organism has a particular genetic code which defines that particular living organism, which tells you the characteristics of that living organism. Now, let's suppose that someone is suffering from a genetic disorder. Now, what are genetic disorders? Genetic disorders are those diseases that happen because you have faulty genes in your DNA. All right. Now, what we can do through gene editing is we can cut those faulty genes from your DNA strand, replace them with normal genes. So, for example, someone is suffering from thalassemia or leukemia. Both of them are genetic disorders, and they happen because of certain faulty genes in your DNA segments. Okay, in your DNA. Now, through gene editing, we can replace those faulty genes, and we can actually replace those faulty genes with a normal copy of a normal gene. Okay, and through that we can cure thalassemia, we can cure leukemia, we can cure Huntington's disease, we can cure Parkinson's disease, and many other genetic disorders. All right, so gene editing is used to change the features or change the DNA of any living organisms. You know, gene editing is used to produce genetically modified crops as well. There are certain crops that resist various insects, right? That happens because scientists actually change their genetic makeup, change their DNA segments, and make them resistant to various insects. They make them resistant or tolerant towards harsh climatic conditions. You can change the characteristics of any living organism through genetic editing. All right. Now, what these two females have done, what these two female scientists have done is they created a new technology called CRISPR-Cas9, through which gene editing became more simple, efficient, and less time consuming. So they improved upon the previous genetic gene editing technologies. All right. This is the first time a Nobel has been awarded jointly to two women after decades of criticism by the scientific community for overlooking female scientists for Nobel prizes. All right. Charpentier and Doudna's work was described by the Secretary General of Royal Swedish Academy of Sciences, which hands out Nobel Prize, as rewriting the code of life. Now, these genetic code, these are any living organism's genetic makeup actually describes that organism. It's the code of life. All right. Now, through CRISPR-Cas9, you can edit that code of life. That is why he used the phrase rewriting the code of life. All right. Let's move forward. Let's talk a bit about CRISPR-Cas9. What's the full form of CRISPR? Clustered, regularly interspaced, short palindromic repeats. Now, what is Cas9? Cas9 is a protein that acts like scissors, right? I told you about gene editing. Now, what they do is that they cut the faulty gene and replace it with a normal copy, with a normal gene, right? So, Cas9 protein is used for cutting that particular, that faulty gene sequence. All right, and CRISPR is used for identifying faulty gene and replacing it with normal gene. Cas9 is used just for cutting. That is why Cas9 is known as genetic scissors. All right. Now, CRISPR technology, CRISPR actually identifies faulty gene. Cas9 removes it, and CRISPR attaches that normal copy of that gene in that genetic sequence. Okay, that's how genetic editing happens through CRISPR-Cas9. Editing or modifying gene sequences is nothing new. It has been happening for several decades now, particularly in the field of agriculture. I told you about GM crops, right? So it has been happening. Genetic editing in crops has been happening since a long time, for a long time, even way before CRISPR-Cas9's discovery, where several crops have been genetically modified to provide particular traits. But what CRISPR, why is CRISPR special? But what CRISPR has done is make gene editing very easy, simple, and at the same time extremely efficient. All right. The technology replicates a natural defense mechanism in some bacteria that uses a similar method to protect itself from virus attacks. Now, the inspiration behind this discovery, or the inspiration behind the development of CRISPR-Cas9, was the immunity or the immune response of bacteria against various viruses. Where some bacteria actually kill invasive viruses in their body, invasive viruses, by identifying their important genes and then cutting them. All right. So they also use similar technology, bacteria, that is naturally inbuilt in bacteria. They also use similar technologies similar to Cas9, CRISPR-Cas9. Okay. So the inspiration behind CRISPR-Cas9 was the immune response of bacteria against various viruses. Okay? Now, an RNA molecule is programmed to locate the particular problematic sequence on the DNA strand, and a special protein called Cas9, which is now often described in the popular literature as genetic scissors, is used to break and remove the problematic sequence. A DNA strand, when broken, has a natural tendency to repair itself. But the auto repair mechanism can lead to regrowth of faulty gene, problematic gene. So what CRISPR does is, what scientists do in this, at this particular stage, scientists intervene during this auto repair process by supplying the desired sequence of genetic codes, which replaces the original faulty sequence. It is like cutting a portion of long zipper somewhere in between and replacing that portion with a fresh segment. Because the entire process is programmable, it has remarkable efficiency and has already brought almost miraculous results. Alright, now let's take a look at the advantages and disadvantages of CRISPR-Cas9. Here are certain advantages. You can cure various genetic disorders through this. You can even cure cancer through this, through gene editing, through CRISPR-Cas9. You can also modify various crops, and that would create many applications for the field of agriculture. All right. So these are the advantages. I would advise you all to read them from your notes. All right. Now let's take a look at the problems associated with CRISPR-Cas9 or problems associated with gene editing in general. Many people actually criticize gene editing. Now the reason for their criticism is ethical concerns. There are certain ethical concerns attached with gene editing. Now what are those ethical concerns? I've taken a screenshot from an article in Indian Express. You can read that. But the crux of this article or the crux of this these paragraphs is that genetic editing can be used to produce designer babies. You see, in November 2018, a Chinese researcher actually altered the genetic makeup of an embryo, right? Now, many people say that you can change the genetic makeup of a child, but of an embryo. By that, you can produce designer babies. Designer babies, by that I mean that, for example, I'm a rich person and my wife is about to conceive, right? Now, I want my kid to be tall, my kid to be muscular, my kid to be broad, my kid to have blue eyes, my kid to have fair complexion. I can achieve all of that by hiring a scientist who's an expert in CRISPR-Cas9 genetic editing technology, and I can tell him to change the genetic makeup of my soon-to-be son or daughter. Right? Most probably son, okay? Now, because I described the features of a son, tall, dark, handsome, and all that stuff. Anyway, now, so I can do that. Therefore, I'm venturing into the territory of designer babies, and that is ethically wrong. Why people say that this is ethically wrong? Because certain religious groups say that it is interference with God's work. You will be interfering with God's work, and that is not ethically correct. Plus, there might be certain unintended consequences because of this. All right. So this is something that we need to be afraid of. All right, designer babies, and that's what is written in these paragraphs, in these lines. All right, makes sense? So yeah, let's move forward. Nobel Prize for Women. This is the controversy that I would want you guys to read it yourself. I have shared some screenshots from an article in the print newspaper. One is this and the other is this. I would want you to read these two articles or read these two screenshots. Why? Because role of women in the field of science and technology can be asked in your UPSC mains. So if you need some fodder for your answer with respect to that question, you can read these two, this information. You can extract information out of it and use it as fodder for your answers. All right. This will be very instrumental for writing role of women. There might be an essay. You can have an essay on a role of women in the field of science, or a role of women in STEM technology, STEM. Science, technology, engineering, and mathematics. Role of women actually in the field of science and technology. You can find some material for writing that answer from these two things, and I have provided these screenshots in your notes as well. So I would want you guys to read up on them. All right, let's move forward. Let's talk about SMART test. Now, what is SMART test? DRDO actually conducted a SMART test. They actually tested a torpedo. Now, what is a torpedo? Torpedo is like an underwater missile. Various submarines launch these torpedoes. They are like missiles, and through that they can hit various ships and other submarines. So it is generally used for sea warfare. or marine warfare. All right. Now what DRDO did was that it created a torpedo which achieved speeds of around more than the speed of sound. It was supersonic in speed. They were able to test a torpedo that had supersonic capabilities, plus it had longer range. Generally, torpedoes have short ranges. This particular torpedo had longer range. The reason for that is that it was mounted on a missile system, and then that missile was launched. Half the distance was covered by that missile, and from that missile, a torpedo is launched. So therefore, technically, that torpedo has traveled longer distance. All right. Plus, that particular missile is traveling at supersonic speeds. So that torpedo is also traveling at supersonic speeds. All right. So it is missile assisted, and that's what the full form of SMART is also. SMART's full form is Supersonic Missile Assisted Release of Torpedo, and DRDO conducted an experiment and they were able to successfully conduct this experiment. What is a torpedo? The definition is given over here. These are self-propelled weapons that travel underwater to hit a target and are limited by their range. They have short range. This SMART system comprises a mechanism by which the torpedo is launched from a supersonic missile system with modifications that would take the torpedo to a far longer range than its own. All right. The test was conducted from Wheeler Island off the coast of Odisha. Okay. There is an island off the coast of Odisha called Wheeler Island. Generally, various space launch vehicles and various missiles are tested on this island. An anti-submarine torpedo of the lightweight category was used in this experiment or test. The test follows another crucial test 2 days ago of the nuclearly capable Shaurya missile. Now, this Shaurya missile is a land variant of K-15 missiles. What are K-15 missiles? These missiles are launched from submarines. Okay, so they are generally used for marine warfare, and they are nuclearly capable. Their land variant is called Shaurya. All right. So all these experiments, all these tests actually show that India is very serious about marine warfare. Why? Because India thinks that their theater of war against China would be Indian Ocean region. It won't be Himalayas. Himalayas are not that significant. Border warfare, land warfare between India and China is not that significant. India and China are going to fight, or their battle would bear significance if they fight in the Indian Ocean region. Indian Ocean region is a very important region, and many global powers are interested in this region. So the next theater of war between India and China would be Indian Ocean, and for that our navy needs to be capable enough. All right. If India wants to be the net security provider of Indian Ocean region, its naval supremacy must be ensured. All right. And that is why we are conducting these tests. We are testing these missiles, these torpedoes, so that we can make our navy better, more capable. All right. Now I have shared again I have shared a screenshot explaining why this particular test is significant. So please read up on this also. All right. With that, we are done with our science and technology related current affairs. I hope you enjoyed the lecture. If you have any doubts, then please write to us those doubts on your WhatsApp groups or on your app. On your app, you can send your doubts. Okay. So that's it from my side, guys. I'll see you next time with more stuff. Thank you.